Hello, Thrive Nation. I've got an incredible guest that I've waited quite a while for, and he is an international hero. He's a medical doctor. He's a PhD, an assistant professor at the University of Washington. He's done his PhD in neuroscience and physiology. He's been on many podcasts. He is well published in terms of papers, research papers. It's a privilege to have Dr. Tommy Wood on the show. Welcome to the Made to Thrive show.
Thanks so much for having me. It's a pleasure to be here.
Great. So, Dr. Tommy, I do want to call you Dr. Tommy. I know they call you Tommy on many shows because my audience well knows that the Latin root of doctor comes from docere, which means teacher. And I'm on a mission to educate and teach people about health, to prevent disease and sickness, and rather be focused on healthcare than sick care. So, the father of medicine, Hippocrates, said the greatest medicine of all is to teach people how not to need it. So give us a quick backstory about Dr. Tommy Wood and his teaching and his published papers, and what your mission is. What is your purpose and what is your why in the world?
Yeah, sure. So I have a rather complicated, or we'll just say wandering backstory of how I got into health. So as a kid and basically into my teenage years, I didn't really care that much about health. I spent most of my time sitting in front of the TV, seeing how many chocolate biscuits or cookies, depending on which country you live in, I could eat after school. And then sort of as I went into university as an undergraduate, I started to get more interested in health and training. And as an undergraduate, and then at medical school, I was a rower. That was my main sport. And along with that actually came a lot of, I was probably hyper focused on those things. Something akin to what we might now call orthorexia. I was very hyper focused on my diet and my training and my physical appearance and sort of the negative things that can come with that and are increasingly common. I sort of had an experience with that the first sort of 10 years of my health focused life. And as I went into medical school, I as well as training, I became increasingly interested in nutrition. I had a period of time where I worked on multiple sclerosis, specifically kind of separate from the performance aspect, but because my stepbrother at the time was diagnosed with multiple sclerosis, and sort of we tried to figure out, what might be the various components that not necessarily cause it, but at least increase risk and maybe influence sort of disease severity and progression, and sort of all kinds of things pop out in terms of diet and genetics, of course, and nutrient status and toxic exposures and chronic infections and all these kinds of things that, then start to form the basis of things like integrative medicine, functional medicine, lifestyle medicine, ancestral or evolutionary medicine. There are multiple different ways of describing the same thing, essentially. And so that kind of got me interested in that arena. And as I finished, or I guess started my PhD first, I got to spend more time. Actually digging into the research. You have access to PubMed. I'm sat at a desk all day, as well as sort of like my main research. I could sort of get into that. Started a blog, a podcast, and then that has kind of continued along the side as I've done my academic work. So most of my published work is in neonatal neuroscience, so finding ways to treat the injured newborn brain. But I also have publications in sports science, the gut microbiota, various aspects of neurodegenerative disease across the entire lifespan. That's where I focus my work now. So what can we do to make a healthy developing brain, and how can we keep that brain healthy for your entire life? That's kind of what underpins the day-to-day aspects of my job now. But I do actually work, or have worked and continue to work, with a number of athletes. So I spent some time as chief scientific officer of a company that provided sort of I guess we would call it functional medicine for athletes. So we did gut testing, blood testing, some urine testing. We looked at, sort of deconstructed the whole lifestyle of these athletes to try and either restore their health or make sure they're as healthy as possible for as long as possible, and could keep performing for as long as possible. And that's something that I still do a bit of. So I work particularly with Formula One drivers currently, doing similar things. and sort of alongside my work in neuroscience across the entire lifespan. So
Sure.
that's kind of the long answer to your short question.
So you're an academic as well as a clinician, which makes a very powerful combination. Obviously, deep in the research, published a lot of papers. And so I do want to sort of set a bit of a frame. I do want to talk about brain health, the developing brain. I've had a second child after 12 years of infertility. I got a 17-year-old and I got a 5-year-old. And it feels like I got a fresh start to this 5-year-old. I feel like I've got a sponge. I've got so much more, experience and knowledge in the medical field. But I do want to start with something that I think is very important, because if we're going to have long-lasting change, which is something that I really want to dive into in terms of my own mission and sort of mandate, is that so many people change their lives in the short term. I've been a clinician for 23 years, probably done over 150,000 treatment sessions. I've seen people come and go. I've seen people adopt a healthy lifestyle. 6 months later, they're back to their old ways. Give us some key sort of understanding and takeaways of how we can help people maintain their sustained transformation.
Yeah, I think that it's probably the most important question that we have facing us in this arena right now, and actually does feed into my why, which I didn't really answer that aspect of your question previously, and it's to help people or support people in changing their environment and lifestyle if they have the interest and ability to do so, and to help show that it's actually not as difficult or as complicated as people tend to say that it is. So I spent a lot of time working with biohackers, elite performers, the optimizers who want to like change everything and fix everything and optimize everything. And I think when you work with that group, it's beneficial to a certain extent, because they'll essentially do whatever you say and they'll keep doing it. But the vast majority of people don't have the ability or time or access to be able to do things like that. And those people are the people that need it the most. And so as I spend more and more time optimizing and biohacking or working with people who do that, the more I have become interested in helping, just quote unquote the average person, which is the vast majority of the population, wherever you tend to be. And so I think one of the most important things that you can take away is that each small thing that you do in one of the areas of lifestyle that we know supports health, each small change that you make fosters additional changes. So it's never about saying, well, we know that sleep and diet and movement and stress and social connection are like the underpinning factors that support human health. It's not like you have to fix all of those and make them perfect straight away. And I think that people internalize this idea that that's what you need to do, and it seems very daunting and very difficult, and then you just don't do anything. That's a sort of analysis paralysis. Like, that's all so much, I don't know what to do. It makes it much harder to foster change. So I think celebrating small wins, identifying lowest hanging fruits, like what's the one thing that you think you could do today, and then you can do it tomorrow, and then maybe the day after, and then you do it for 2 or 3 weeks, and then it becomes a habit. And then because you've created that habit, you then foster a drive to change other things. So we know that people who exercise are more likely to quit smoking, or people who improve their diet are more likely to start exercising. So just these small changes that you can make, identify the one thing that you can do, will then help you to do more things going forwards. And I think that's really the critical component, and making people realize that it's probably less than you think. If we think about exercise in particular, there's this modern fetishization of incredibly intense exercise, right? In order to be an athlete or healthy and fit, you need to go out and run for an hour, or you need to sign up for marathons, or you need to go to the gym for an hour or 2 every day, right? And none of that is true. If you can walk for 20 minutes a day, that has a huge effect on your health, particularly if you aren't, walking or moving much already. So like knowing that it's actually not as much as you think it might be in order to dramatically improve your health. Like, that's a really important starting point. And one of the things that I try and talk about more and more is that what you see people do, and we sort of like idolized in terms of diet and exercise and all these other things, that's really not what you need to achieve in order to dramatically improve your health.
Fantastic. So incremental changes that become habits, and starting with very small steps. It sounds like a very, we believe in health coaching, and we believe there's a big chasm between the functional medicine doctors and the specialists and the lay public that have, battle to, execute these incremental changes. But give us your sort of short rundown on how important health coaches are in the future. I've worked with James Maskell from the Community Cure. I know the Cleveland Clinic and Dr. Mark Hyman use health coaches. One sort of functional medicine doctor or specialist will see, 8 patients at the same time with a health coach there, and sort of making functional medicine and integrative medicine more affordable. Where do you see health coach going, and what is your experience with a health coach?
Yeah, so I've, when I've worked in this arena, I've worked with health coaches, and they're a critical aspect to helping support people make these changes, because, as you say, be it the specialist or the physician or whoever's overseeing the project doesn't necessarily have the time to provide the support that an individual needs, and also, I think there are certain times when we can say that improving lifestyle or adjusting our environment to improve our health, that doesn't need to be in the hands of a doctor, right? We're not trained on these things. Actually, we can learn it, and that's what I've done myself, but it doesn't need to be the arena of a physician, because health coaches often have more sort of boots on the ground, daily knowledge and appreciation of what it takes to make these changes. So I think that they can be and are very important. There are a couple of potential issues that I guess. One is that still most people don't have access even to a health coach, or the vast majority of people may not have the funds to be able to afford access to a health coach, and that becomes a problem. So it needs to be, depending on the medical system that you're in, it needs to be part of that system and accessible to as many people as possible. The next thing, and one thing that I think that I am hopeful will happen, even though it may negatively impact health coaches, is I hope that we can get to a point where we can automate a lot of these processes, because again, that increases accessibility. So I think there are a number of digital health companies that are trying to find ways to, at least provide the bulk of the support and change that a health coach can provide. And then do this through an app or some online tools, and that can include interaction with humans, but doesn't necessarily need like long sessions with a health coach. And I think again that's important because it can make it cheaper and accessible for more people. So health coaches are incredibly important, but I hope that at some point we'll be able to create some automated processes that can provide the same, or at least the bulk of the same support, so that we can get it to as many people as possible.
Fantastic. And I want to talk about brain health, Dr. Tommy. And I want to just, if you could answer sort of within 2 silos. One, from a child's perspective, I got a 5-year-old. I'm looking at my 5-year-old. I want to really maximize and optimize their brain health. And then sort of from a cognitive decline, or from a Parkinson's, Alzheimer's, those type of neurodegenerative conditions that are increasing exponentially. If we look at the 7 pillars of Made to Thrive, and if you can just comment on this, because the 2 things that I'm really trying to focus with my daughter is purpose and community. So every single day, it's almost, call it brainwashing, call it a meditation tool, that she has a unique purpose. She has a unique value add in this world. She carries a unique thumbprint, a unique influence with regards to her nature, how she was born, and her nurture from an environmental point of view. And then secondly, a community that she serves with her gifts and her talents. And these are the 2 things that I've really implemented in her life, because I feel they're fundamentally important. That, people would wake up on a Monday. We've got this acronym TGIM, thank God it's Monday, that people would see Mondays as valuable as a Friday. But the world seems to say that weekends are very pleasurable and holidays are pleasurable, but work is not good, and work is, there's suffering and pain. So these are 2 important pillars that I think are crucially important. What does the research say, possibility on community and purpose and knowing your why, and how important that is from a fundamental basis?
Yeah, I mean, I completely agree. I think those are incredibly important things to have, essentially across, both starting right at the beginning of your life and then continuing it right towards the end of your life. And I think what has been most striking for me, the more time I spend looking at these different periods of development or susceptibility to either an injury or decline, is that essentially you need the same things across the entire lifespan. Like it doesn't necessarily change, and we're kind of told that, you know, your brain develops, and we've moved out when it finishes developing. Now we may think it finishes developing in the mid-20s or late 20s, early 30s, when you sort of like finally myelate, your prefrontal cortex is fully developed, you are finally the human that you are going to be. But then the brain is not rigid after that. You know, it is surprisingly plastic even after that period of time, as in it is able to adapt to change and develop new connections and new skills. And we've sort of told ourselves that that's not the case, but really our brains are fantastically adaptive over time. And so if you think about the things that you mentioned, it's really important to have, so I have like a model of what the brain requires, and it essentially needs three broad things, which are materials, protection or security, and then connection, which is connection to the outside world. You need to tell your brain that it is a useful thing to have, because just like a muscle, if you don't use it, you don't tell your muscles that they're useful, then they're an expensive thing that there's no point in keeping a hold of, and your body will actively get rid of them, and your brain seems to be exactly the same. So one very important thing that our brain needs is to be told that it's useful and that it has, you know, some purpose and connection to individuals, and the greater society. And there's lots of data showing how social connectedness protects against cognitive decline, how some kind of purpose or, you know, feeling of that your life has meaning, you know, is supportive of long-term health, and, you know, associated with lower mortality and occurrences of mental health. And I think that starting this early on is very important, because there's, you know, an increasing burden of mental health amongst, you know, younger children, you know, teenagers, adolescents. And I think, you know, telling people, you know, you are loved and needed and you have purpose, and showing them, or giving people the ability to sort of provide that to other, you know, be it in the service of others or finding some other way to be connected to others and work towards a purpose greater than themselves, I think is incredibly important, both for mental health and then, you know, long-term cognitive function. So that's one of the critical components of brain development, is connecting to the outside world, you know, which is part of, you know, developing our motor skills and developing our social skills and developing language skills, which are essentially how we wire and develop our brains in the first place. And then we need to use those out in the world and keep using them and developing new skills in order to maintain cognitive function over time. So it's like, it sort of underpins one of the main things that our brain needs for long-term health.
Good, because I mean, there's a meme now that the lowest hanging fruit and the biggest way you can bring transformation and change is to change your diet. I found it's the lowest hanging fruit, but it's the hardest to take the fruit off the tree. And you know, what is very, very easy to do, or what is very simple, is actually not easy. So people say, just change your diet. It's simple, you know, just change it, but it's not an easy thing to do long term. But underpinning that, the motivation or the internal drivers are, you know, if I'm waking up and I need to perform and I need to function correctly, then it's my purpose and the people that I'm actually sort of expressing my gifts to in the world that are going to say no to that chocolate cake on a Monday or no to the donuts on a Tuesday. It's that internal driving that comes from purpose and community.
Yeah, I agree. But again, I think we've sort of underappreciated this aspect of human health, but I'm also glad that that's starting to change. So when you look at sort of movements again now in medicine, things like group consultations are becoming part of standard sort of general practice in the UK in particular, where I work as part of the British Society of Lifestyle Medicine. And that's, you know, you're taking individuals who are, you know, maybe they're connected by a certain disease, but they live in the same place. They're probably likely to be, you know, similar people. They can go and learn about things together, you know, on activities. So you have group consultations around cardiac disease and they go walking together. And so you have this combination of movement plus friendship plus, you know, developing some kind of purpose and connection to others. There's also a fabulous work by Julian Abel and others with compassionate communities. So they've basically created community support networks that have dramatically reduced A&E, you know, emergency hospital admissions in the places that they've instituted it. And they worked in a small town called Frome in the UK, and they're now, you know, putting that approach to, across to cities. And I think that even cities in the US, they're going to start trying to do that. So it's incredibly important, like for our individual health, but also for community health and, you know, maintaining healthcare systems and all these things, very important. But again, I think it needs to be done at, you know, a large level and have some top-down component, because when people are socially isolated, and there may be health reasons for that, there may be financial reasons for that, there may be other socioeconomic factors that drive that. You know, it's very easy for you to say, you know, hey, you should have a purpose and you should have friends, but, you know, particularly if you're starting from a place where you have some kind of mental health issues, or, you know, all these other factors come into play, you know, sometimes it's hard to go and find a community and find friends and find a purpose. So I think, you know, it can be, depending on the individual, can be similar in terms of struggles to change your diet. So building these communities, building this infrastructure that allows this to then happen, you know, it doesn't have to be a sort of an individual approach. I think it's going to be really important as well.
Fantastic. And another pillar is nutrition, obviously, and how important that is for, you know, your brain health. I want us to take a sort of a deep dive in CGM, continuous glucose monitoring. I think it's something that's crucially important that people should be able to do, or at least measure their glucose daily, and then look at insulin. And we've got probably 10 top blood tests that I believe we need to educate the public in South Africa and Africa, that they should know, that they should understand, that we should be able to educate them on. Fasting insulin is incredibly important, I think, and that people need to know this marker, what it is. I think it's not recognized by many physicians. So tell us a little bit. I know that you're an insulin resistance expert in terms of the research and what's been happening and how important that is. Many people have high insulin. They don't even know. They do the glucose test. They do the HbA1c. It all looks good. The doctors gives them a clean bill of health, except their insulin is really, really high. They're really insulin resistant, and they're not looking at a continuous glucose reading, knowing, hang on, actually the food that I eat here, this food is possibly not the best for me, because it's giving me glucose spikes.
Yeah. So again, if we tie that, you know, start by tying this into the brain, some people have called Alzheimer's disease type 3 diabetes. So it's basically insulin resistance within the brain, and then you have reduced ability of the brain to get the energy that it needs in order to function, which can then be associated, you know, then it has to decline in its function because it just can't support the function that it needs. And if you look at even early stage changes in glucose regulation, as we might call it, so something like pre-diabetes, so you just have an elevated fasting blood sugar, but you wouldn't be called diabetic, you wouldn't necessarily get any interventions, then that's even associated with a dramatic increase in the risk of cognitive decline or dementia or Alzheimer's disease, depending on how you diagnose it. And this starts very early in life, and we know that it's very common. So probably at least 80 to 90% of the adult population in westernized societies have some degree of insulin resistance or metabolic disease. And this is essentially a function of our environment and our diet. So, you know, including some of the pillars that we've already talked about, but, you know, diet in particular. And there's some very nice data that says that your cognitive function is directly tied to your glucose variability. So this can, if you looking at papers, you might find something called the MAGE, which is the mean amplitude of glycemic excursions. And in some studies where they've looked at this, the bigger your MAGE, so basically the more variable your blood sugar is, the worse your cognitive function is. And importantly, it's reversible. So if you decrease your MAGE, in trials they've done this with medications, but I believe you can probably do it with diet as well. So if you decrease your glucose variability, you can then improve your cognitive function even as an older adult. So again, the brain isn't, you know, fixed in the way that we're told that it is. And so you then might want to think, well, what are the things that cause these big swings in my blood sugar? And the problem is that the more we learn about blood sugar, the more we realize that it's impossible to predict from one person to the next. So we used to talk about things like glycemic index and glycemic load. And to be honest, I think those should just be retired. They're essentially nonsense, because when you look at how one individual responds to the same food, it is so variable, and it's based on genetics, gut microbiota, the context of the meal. Like, did you just work out? Have you just woken up? Is this breakfast? Is this dinner? It depends on what else is in the meal. It depends on your overall metabolic health. So your HbA1c is a better predictor of your glycemic excursions than the carbohydrate content of the food. And so we're now getting to a point where I couldn't tell you whether a certain food is good or bad for your blood sugar, right? You could have a piece of cake, and for you, actually, your blood sugar doesn't change very much, but mine changes a lot. And it's surprising and fascinating, but then introduces a problem, because we can't just say this food is good or bad for your blood sugar. And so continuous glucose monitoring, I think, can be the thing that allows us to bridge this gap. And you probably only need maybe 2 to 4 weeks of data, because we just eat the same foods again and again, right? You don't need to see, so let's say you have cornflakes for breakfast, right? You don't need to see this big blood sugar spike after your cornflakes 12 times. You probably need to see it twice, right? And so the main downside that I have about continuous glucose monitors is that, again, in the sort of the optimizer biohacker group, like, they wear them for months and years on end, which I would argue is unnecessary and potentially problematic, because you become hyper focused on this thing that introduces its own stresses, and then affects social relationships around food and relationships to food and all these things. So I think small periods of data, 2 or 3 weeks, see how you respond to the foods that you eat again and again. And you say, well, do you know what? Maybe cornflakes aren't the breakfast that I should eat, because they cause a bit of blood sugar spike, and you eat something else. And so I think it can be incredibly important. And again, there's huge debates about this, who's, right now, the people who are doing it are probably the people who don't need it, like some of the things that we've talked about. Whereas if we can get it to the people who do need it, the majority of the population who don't understand necessarily how their food affects them, then I think this could be really impactful. So again, it's just, connecting people to these tools and making them available as part of the healthcare system, I think, can be really important.
Great. And tell us about fasting insulin. I think it's an incredibly important marker, and it's something that should be looked at, I think, from individuals, that don't know much about health. I think it's one of the top 10 markers. Tell us about the research and what fasting insulin sort of just shows us.
Yeah, sure. I think it's worth bearing in mind that so we talk about insulin a lot, and people become very hyper focused on insulin and try and say, well, insulin should be as low as possible. And there's nuance to that maybe that's not necessarily the case. So again, if we just blow this out to the general population, when I talked about pre-diabetes, elevated fasting blood sugar sort of predicts cognitive decline, and this starts very early, what happens before your blood sugar is raised is that your body starts releasing more insulin to keep your blood sugar down. So you could have normal blood sugar whilst insulin is higher. And so you can pick that up much earlier by looking at insulin, or the ratio, or certain ratio of glucose to insulin, something called the HOMA IR, which you can calculate if you have your fasting glucose and your fasting insulin. And this correlates with, predicts later metabolic syndrome, it predicts later type 2 diabetes, it predicts later dementia risk. And again, you can pick it up before you see these changes in blood sugar that are what might be picked up by a doctor with, fasted blood sugar or HbA1c, because your insulin is working harder to keep your blood sugar low earlier on. So again, insulin is very cheap. Any doctor can measure it. A HOMA IR is easy to calculate. And I think it would be, it's something that, again, because this is so common, if you say 90% of the adult population have some degree of metabolic disease or insulin resistance, we can pick this up much earlier. And then maybe, again, the problem is not necessarily knowing that you have it, it's then changing the things you need to change in order to improve it. And then that's where these other things come into play.
Great. Fasting is one of probably the greatest nutritional tools that I've used with many patients and clients. I think it's not for everyone. Obviously, there's caveats to fasting, intermittent fasting, or time-restricted eating. Give us your view on how important it is, from apoptosis to autophagy, and what it does to insulin and the production of ketones, beta-hydroxybutyrate, acetoacetate, on brain function, and just how important this keto diet or keto cycling or keto fasting is important for people to develop metabolic flexibility?
Yeah, in reality, I don't think any of this is necessary for an individual in order to improve their health. And the more time you spend working with people, the more you realize that any one approach isn't necessary. And so I used to be big into low carb and keto, and I still am. I myself eat a pretty low carbohydrate diet. I've spent periods on ketogenic diets. I think they're incredibly powerful tools, but not necessarily necessary for health. And that's kind of the difference between what's a tool to use in a certain scenario versus like what should everybody be doing. And the main benefit of fasting, time restricted eating, is that people may find that simpler to do in order to reduce their overall caloric intake, because one of the main reasons why people have metabolic disease is because they have, for their own personal health status, and lots of things feed into this, they have too much adipose tissue stored on their bodies. And there are multiple different factors that affect how much you can store before it affects your metabolic health. And so the reason why most diets are beneficial in terms of metabolic health is you lose weight, and specifically body fat is the effect there. And so fasting, for those who find it a useful tool to adhere to, is probably most beneficial in that respect. But you could do it anyway in terms of improving diet quality, nutrient density. I've seen it work everything from a whole food plant-based diet to a ketogenic diet to everything in between. Or any of those can work depending on the individual. One of the sort of the downstream effects of extended fasting, like you said, is an increased production in ketone bodies like beta-hydroxybutyrate and acetoacetate. And I think these are particularly important at like the bookends of life. So babies are naturally in ketosis, at least for the first week of life. And this is a combination of either fasting ketosis because breast milk in mothers doesn't come in immediately. So babies don't necessarily eat all the time straight away. And then they have lots of body fat stored so they can produce ketones that essentially supports the metabolism of the brain. And that's the reason why humans are the only primate that has a baby that is born with significant amounts of body fat, is to support the brain through production of ketones in the first periods of life. And we talk about ketones in terms of energy metabolism, but what ketones are really important for is as a synthetic precursor. So your brain uses ketones to make structure, to make fats, to make cholesterol that form the majority of the substance of your brain. So it's important in the developing brain, and breast milk contains, the breast tissue specifically synthesizes medium chain triglycerides, which people may know are ketogenic fats. So there are ketogenic fats in the breast milk. So even though the breast milk has lots of carbohydrate in it, you still produce ketones because of the MCTs in breast milk, and they are used to build the structure of the brain. And so I think this is then important if you have an acute brain injury later in life. So you have a traumatic brain injury or a stroke. If you want to repair the brain, you're going to need to rebuild structure, and then ketones become very important. And then later in life, say you do have some degree of cognitive decline, Alzheimer's disease, like we talked about, there's some insulin resistance in the brain, glucose metabolism of the brain decreases, and you can overcome that by providing ketones instead. And you could, there are multiple different ways to do that. You can either fast a ketogenic diet, you can supplement with ketones, and there's now increasing evidence that suggests that improves cognition as well. If you were across your life to take better care of your brain, you never become significantly insulin resistant, you never get a traumatic brain injury, you probably don't need to go into ketosis late into life. But these are things that could be beneficial after your brain has had sort of a lifetime of various things that have gone on, and then it becomes important again. The last thing that I wanted to touch on, people talk about fasting and autophagy. So that's basically the recycling of waste proteins, damaged organelles inside our cells. This sort of, when you start to fast for prolonged periods, then you activate these pathways that sort of turn these over. And people talk a lot about fasting and autophagy, but the problem is that we don't really know what amount of time or what kind of structure of fasting, maximally increases autophagy in humans. So like, how long should you fast in order to get these benefits? People will tell you that they know, but we don't know, unfortunately. And again, one of the things that I think is great is that you don't need to fast to get autophagy, because the best way to activate autophagy in a short period of time is to exercise. So they've done studies where if you fast overnight, so an extended period, 12, 16 hours, you don't get much autophagy. So you wouldn't get much if you were doing like time restricted eating or something. But if you do a 30-minute bike ride, all of a sudden autophagy gets activated, and you see the same things in animals. I have guesstimated, based on like correlations between what we see in animal studies, looking at autophagy in all the different organs versus what we've managed to measure in humans, that you probably need to fast for 3 days to get the same amount of autophagy activation as going for a 30-minute run. Wow. And I don't know about you, but I prefer the latter approach because I don't feel great when I fast for long periods of time, probably because I have a lot of activity and muscle mass and stuff like that. So I think, again, just empowering people to know these things, right? Yeah. You don't need to fast for 3 days in order to get autophagy. You could just go for a brisk walk. I think that's great. And you pick whichever one is best for you. I have no strong feelings about what you do for yourself. Just know that these options exist.
Fantastic. And I think I learned something new there in terms of taking a 30-minute run or bike and, just really stimulating autophagy. That's important. Yeah. Tell us about the next. So we've done purpose, community. Now we've looked at nutrition, looked at fasting and CGM, insulin. Your circadian clock and environment, how important that is, the lymphatic system and how important that is at night. And elevated glucose and your body fighting to keep that glucose down if you eat just before you sleep, and how important light is and your circadian rhythm, and Sachin Panda's work on when we should be eating for brain health, because I think that's crucially important. I think the mind and your brain now, your cognitive performance with COVID, whether you're a teenager, a 5-year-old, an 80-year-old, this is crucially important.
Yeah, I'm a big fan of Sachin Panda's work, and he's a good friend of mine. And he's really kind of brought this to the forefront, I think, in the last few years, which is great, because even 5-10 years ago we didn't really appreciate the nuances of circadian biology, when in fact, like, almost every cell in your body runs on a clock. In fact, every cell in your body does run on a clock, which means that the proteins you're synthesizing, the materials you're using for energy, they change across the day, and as they should. And there are periods of time when you are highly active, and there are periods of time when you should be repairing, which is usually when you're asleep at night. And when those are mismatched, that is associated with an increased risk of things like diabetes, certain cancers, maybe heart disease, because there is an expected clock that your body runs, and it should be well timed. And so ideally, you'd be exposed to bright light during the day when the sun comes out, and it doesn't need to be that bright. You just need to be outside. So even if it's like here in Seattle and it's dark and it's raining, that's still enough light for my body to entrain its clock. But being inside, even if you have bright lights inside, is actually much less light, even though you might not appreciate it. So being outside early in the day, and then darkness at night is the other side of that. And if you're exposed to bright light during the day, you kind of buffer against some of the effects of light at night. But light at night, has a number of problems in terms of affecting your sleep, and maybe again affecting some of these other disease processes. If you're not exposed to proper light during the day and darkness at night, then other cues, Zeitgebers as we call them, which is German for time giver, other cues become important. So this is something that Sachin has talked about, which is that food timing becomes probably more important if your light cues are out of sync. So then, again, eating within sort of maybe 10 to 14 hours, right? So there's a daytime activity period, which is when you eat, and then there's a nighttime and rest and recovery period, which is when you don't eat. And one of the most fascinating outputs of his work is that essentially modern humans, he says, when our eyes are open, our mouths are open, which basically means that we eat from the minute we wake up until the minute we go to sleep. And that's incredibly problematic because that's just not how our bodies are designed to function. And again, I think this is complicated by the modern food environment. So, if we lived in a more ancestral food environment where food isn't calorie dense, and it's, it is nutrient dense, I think if you had an extended feeding period, it probably wouldn't matter as much because you just can't physically get in the calories you can get in, particularly when you're eating late at night. So when he's done studies looking at the feeding window, if you get people to restrict what they eat, say in the 3 to 4 hours before bedtime, you dramatically improve diet quality. Because what do you eat at 9 p.m? You eat chocolate and ice cream and cookies, and maybe you wash it down with a beer. And so you suddenly take out this period of time when we eat, quote unquote, the least healthy foods that are in our diet for most people. So you can, by restricting the timing, the feeding window, you can help train your circadian clocks, which has its benefit. And then you might also automatically improve your diet quality just because you're not eating in a time when you probably don't eat foods that are going to be supporting your health goals.
Yeah.
And then the final part of that is, and again, at this point, it's subjective. Like there's no really good evidence to support it, but Sachin has reported that in the studies where he's had people restrict their feeding window, they've kept doing it after the study because they sleep better, because they're not eating immediately before bed. And again, like when you're sleeping, you're meant to be in this sort of like rested state. But if you're actively digesting, that sort of, butts heads up against, what your body is trying to do. Like it's trying to rest and recover, but at the same time, it's actively trying to digest food, and those things aren't necessarily compatible. Again, there's always a caveat. The caveat to that is in highly active individuals like athletes who will often sleep better if they eat something right before bed, just because they're in such a calorie deficit that they need those calories before they go to bed. So there's plenty of data in resistance trained athletes or other athletes where if they have like a protein rich snack before bed, they sleep better and they recover better. So again, it just depends on the individual that you have in front of you. But in general, people often report sleeping better if they don't eat in the 2 or 3 hours before bed.
Great. Another part of environment is radiation, electromagnetic radiation, and brain health in terms of kids, how thin their craniums are, and the older generation holding cell phones and Wi-Fi's. What has it shown? I know Dr. Daniel Amen's work on using the SPECT. I'm not sure what your view is on that, but radiation and neurological conditions, and what we're seeing an exponential increase in brain cancers and that. What is Dr. Tommy's view on that?
My view on that is that it's really complex and I don't have a great answer. So if we go to, so I think there's a lot of alarmism in electromagnetic fields and health. And I think that's been necessarily derided. People have said, this is being blown out of proportion. And based on the evidence that we have, I would tend to agree. However, it's worth bearing in mind that there are certain countries that have banned some of these things. So like in Sweden, you can't have Wi-Fi in schools because there's enough of a question to say, is this something that A, we need to have in this scenario, and B, is there a possibility that it may have a biological effect that could be detrimental? And sort of that's probably where I am. I would say that from a basic physics point of view, we know that electromagnetic fields interact, right? We know that our mitochondria produce electromagnetic fields because they move electrons through space, which is what generates electromagnetic fields. So it is likely that EMFs will have a biological effect, but I don't know how big that effect is. It may be so small that once you take into account diet and movement and sleep and all these other things, that it doesn't really matter. That's very possible. And certainly you see dramatic improvements in people's health, despite the fact that we're bombarded with various man-made EMFs. You can see dramatic improvements in health by fixing those other things. So I'm at the point where I'd say, I think that there probably is a biological effect, but I'm not entirely sure whether it's something we should be really worried about. So I'm hedging my bets.
Good. So purpose covered, community covered. nutrition covered, environment, we've looked at light and radiation. The next one would be movement, more movement than exercise, how important it is to keep moving 10,000 steps a day. Is there any research to 10,000 steps a day? And is movement far more important than spending an hour of exercise, of doing anaerobic or resistance training or aerobic exercising, and then sitting for 8 hours or 10 hours? What do you feel about that?
Yeah, another great question. And I'm certainly very, I personally enjoy exercise as we think of exercise, you know, in the modern form, but I think movement itself is more important. So we start by talking about walking. I think everybody should walk more. It's something that almost everybody has access to, is able to do. It doesn't cost anything. 10,000 steps a day has, you know, everybody, like, it's so funny because either some people are like really pro 10,000 steps a day or are like really against 10,000 steps a day. And like, it's arbitrary, but that doesn't mean it's not beneficial. So there are some of the original studies done on 10,000 steps a day basically looked at, well, they tried to find a number that was quantifiable that they could target in population-based intervention. So it's essentially, it's 100 steps a minute for 100 minutes. Like that was the goal, right? So then that also defines brisk walking, which is brisk walking is technically you're taking 100 or more steps per minute. So it was just like something easy to remember and instigate 100 steps a minute for 100 minutes. Great. And when you look at sort of like the epidemiological data, you know, people will then say, well, hey, you don't need to do 10,000 steps a day because, you know, the benefits start to sort of like level off at like 8,000 steps a day. Yes, that's true. That's great. And so that's probably where the majority of the benefit is. You know, once you get to like 8,000 steps a day, somewhere between 8 and 12,000 steps a day is like the, you know, where you get diminishing returns. So like more steps than that doesn't seem to be associated with improved mortality risk or disease risk or anything like that. Right. Now, the most important thing is that if you're below that threshold, wherever it is, 8 to 10,000 steps, depending on the study, 8 to 12,000 steps, is that there's a linear benefit wherever you are on that slope and you add more, right? So if you start at 1,000 steps a day and you increase that to 2,000 steps a day, you get a huge improvement in your health and reduction in your disease risk. And if you start at 2,000 steps a day and you go to 4,000 steps a day, again, you get a huge improvement. So yes, 8 to 12,000 steps a day is probably where everybody should be for their best health outcomes. But if you're doing less than that, don't think that you don't get benefit unless you do 10,000 steps a day. Because if you're doing 1,000 steps a day, then doing 2,000 is a huge improvement. So I just want people to appreciate that no matter where you are, doing more, even if it's a little bit more, can have a huge benefit.
Fantastic. Brain function, just how does it work with the brain? How does it improve brain health?
Yeah, so there's a very nice study that looked at this, and it was in older adults. I think they were over 60, and it's the first study that ever showed that you could increase the size of the hippocampus of an adult human. And the hippocampus is the part of the brain that's associated with memory specifically, and it, you know, particularly starts to decline and decrease in size in cognitive decline. And they randomized these adults to either do 40 minutes of walking 3 times a week, and they slowly built up over time. So like maybe that you do 5 minutes 3 times a week, and then you go to 10 minutes until you build up to 40 minutes. And then they did this for a year, and they compared it to adults who just did stretching for 40 minutes 3 times a week. And those who did the walking saw a significant increase in the size of the hippocampus. It was correlated with improvements in VO2 max. So basically, the fitter they got through the walking, the better the improvement in their brain. And that in itself was also correlated with production of something called BDNF, brain-derived neurotrophic factor. So one of the ways in which just walking can support the health of the brain is by producing this factor, which is neurotrophic. It supports brain growth. And there are multiple different aspects of this. So walking, you know, or movement decreases inflammation, improves blood sugar control, like all these things. But BDNF is one thing that was at least looked at in this study. So multiple different aspects of movement can support brain health. To kind of go to the next parts of your question, there are studies that suggest that if you just do an hour of exercise a day and you spend the rest of the day sitting down, not moving, the sitting down counteracts a good chunk of the benefits of the exercise. Like not all of it, but being sedentary in itself has its own issues, and it does the opposite of what exercise does, because it increases inflammation, increases oxidative stress, or at least reduces our ability to handle oxidative stress, worsens blood sugar control. So moving throughout the day does seem to be better for a lot of these things. So they've done these studies on movement snacks. So say you take somebody, and for the 12 hours of the day when they're awake, you know, about and at work and at home, they move 5 minutes, right? They go for a 5-minute walk, they walk up and down stairs 5 minutes, you do some squats and push-ups, like any kind of movement. If you do that 12 times 5, that's an hour. If you compare that to those who do the same amount of exercise, but in 1 hour period, you get more benefits in terms of blood sugar control and some other things if you do the movement snacks rather than like the concerted time of movements, like a period of exercise. So again, this just allows you to have options, right? You don't need to go to the gym for an hour. You go for 12 5-minute walks, right? You've achieved all that time period of walking that's associated with improvement in the brain. You've achieved probably something like 6,000 to 8,000 steps just in that period, right? You've ticked all these boxes, and all it took was a 5-minute walking break, each hour, or you could be 10 minutes every other hour, something like that. It doesn't really matter. It all adds up.
Great. So that's probably the most important from movement and exercise, is try and get between 8,000 and 12,000 steps a day. I mean, that's going to be really important.
Yeah, if you do nothing else, that's going to have a huge effect on your health. And again, you can achieve it with just these small breaks. You don't need to say, because understandably, somebody could say, you know what, I don't have an hour to go and walk.
Yeah,
absolutely. I the majority of people probably don't have an hour to go and walk every day, but they may have 5 minutes or 10 minutes a few times a day where they can, build this stuff over time, and that has, the same benefit.
Great. I know we're coming to the end of the show, so I'm going to leave sleep, which is another one of the pillars. I want to move to self-quantification, which I think is really, really important. Obviously, I'm a professional biohacker, and looking at things like heart rate variability. I know we're running out of time, and hopefully we can do this possibly next year sometime. But HRV, the importance of it, oxidative stress, looking at things like inflammatory markers like HSCRP, looking at your T3 to reverse T3 ratio in terms of what's happening from an oxidative point of view, liver enzymes. Where does Dr. Tommy look in terms of these very important blood tests from a self-quantification point of view, including HRV?
Yeah, so HRV, I think, again, something that's cheap, easily accessible. Lots of people can do it. You can now do it with just like the camera on the back of your phone, and it's probably good enough. As with most things that we might track from a quantified self point of view, so it could be a sleep quality, it could be HRV, maybe it's CGMs. When you have very rich, continuous data, the most important thing is trends over time, right? So and the error in the measurement is probably the same within an individual every day, right? So your sleep tracker may not be great at telling you how much deep sleep you have. And in fact, none of the sleep trackers are any good at telling you how much deep sleep you had, but the error is probably the same each day. So if you suddenly had a decrease where it says that all of a sudden your deep sleep cut in half, that's probably, you probably did have a decrease in deep sleep. So generating data over time and looking at trends is probably the most important thing. And HRV is certainly one of those. Like if you just do a one-off HRV measurement, doesn't really tell you very much. I do track my own HRV because my coach likes to track it. As with most markers like that, I must admit that I wish I didn't see the data. I'm not really interested in seeing the data, because if my sleep tracker tells me that I didn't sleep well, or my HRV is really low and tells me that I'm not very well recovered, or whatever, I'm going to have a worse day just because the tracker told me that, regardless of whether it's true or not. And there's plenty of data to suggest that if I tell you that you didn't sleep well, even if you did sleep well, you'll have worse cognitive performance. They've done randomized clinical trials that have showed that. So I think this data can be useful, but it's probably most useful if somebody else interprets it and then tells you about the trends. So that's something that I think we could probably do better in the quantified self arena. So some of the other things that you mentioned, HSCRP, very important. Again, probably being used increasingly in a sort of like an average medical setting. what's interesting is when you look at heart disease, depression, stroke, your risk increases as your CRP increases, but the risk starts to increase within the quote unquote normal range, right? You probably want hsCRP to be below 0.5 or below 0.3, and your risk increases above that, even if the normal range, depending on the lab, is 3 to 5, right? At that point, you're already at elevated risk, even if you're inside the normal range. So we need to be better at understanding, like, when is risk actually increased. I, for various reasons, don't look at like T3 to reverse T3. It's a tricky one to interpret, and there's a number of reasons. So like when stress increases, reverse T3 increases, but it's actually not because we make more of it. It's because the body reabsorbs more of it in the kidneys, and then it kind of turns down, you know, sort of like turns down the metabolism in response to a stressor. So it's difficult to interpret. You need a lot of information about the individual to use it. So at a large scale level, I don't use it a lot. But sort of like an individual, sort of like really detailed assessment, it can be useful. In terms of oxidative stress, one of the best markers that, again, most people can have access to is GGT, gamma glutamyl transferase. Its levels are correlated with glutathione levels within the body. So if your GGT is in like the upper half, again, of the normal range, there's probably some kind of unmitigated oxidative stress that's happening in the body. And we usually just measure the GGT to see whether the patient is an alcoholic, but it has a lot more utility than that. Liver enzymes, again, not very useful in the population that I usually work with, which is athletes, because ALT, AST, LDH, these all increase after a hard workout and can remain elevated for several days. So if an athlete comes to me and their ALT and AST are in the 30s or 40s, it's probably just because they're going to the gym every day and working out hard, and so it's kind of difficult to interpret. But at a population level, just like an average population not training hard can be really useful as well. So one of the things that I've gotten into more in the last few years is that knowing, like, who is this person in front of you, because how you interpret the blood test is then very different. So I work a lot with athletes. I can't interpret blood tests in the same way as I would if this person wasn't an athlete. And as athletes go to doctors, I think they get sort of a short shrift nowadays because that nuance isn't very well understood. So I'll give you an example. I was in hospital for 11 days in Costa Rica because I was bitten by a pit viper in the jungle a couple of years ago. And they didn't want to discharge me because my creatinine was really high. But my creatinine is also always really high because I supplement with creatine and I have a lot of muscle mass. And both of those things increase your creatinine. So they were really worried about my kidneys, but my creatinine is always high. And if you work with a lot of athletes, you kind of see that a lot. So there are these scenarios where we might take one thing and say, well, this is elevated, which means your kidneys are in trouble, but actually it's for a completely different reason. So we just need to be really careful of the person in front of us when we start to interpret these blood tests. Fantastic.
What a show. What a lot of value there. I think we've said more words in 60 minutes than I think ever in my history of podcasts. We've got an incredibly bright, intellectual, very articulate professor in front of us. I thank you so much, Dr. Tommy Wood. Hopefully we can do it next year.